All right, fair friends. This is just my second attempt at recording a lecture. I did geometries first, so now I'm doing you guys. I've already learned a couple tricks, so hopefully you will be able to hear and see everything. Remember, if you have any questions on any of the content that you can't get answered today in class, either text me on Remind. I probably won't get it today during class because I'll be in meetings, but I can text you back after school. Or I will be at the school pretty soon after 3, not like right at 3, maybe around 3:30 to 4. So if you have time and you want to stick around, I'll be here. You can also write it on a piece of paper and put it in the bin. I will be checking those when I get back this afternoon. So if you have a question, just write it down, put your name on it, and put it in the second period bin, which is also where you're going to turn in your homework tomorrow. Yep, that should be good. All right, so I'm going to be doing notes today, or you're going to be doing notes today. So go ahead and get some note paper out. Okay, now the flow will get better as we keep doing this, right? Okay. Okay, so we are finally actually starting a new section that is directly from our book. So we spent some time kind of jumping around and learning some techniques not directly from the book, and we are jumping back in. So we are in section 3.5, solving nonlinear systems. Solving nonlinear systems. Our learning objective for the day is to be able to solve, to solve systems of nonlinear equations and solve quadratic equations by graphing. And you may want some graph paper for a couple of things we're going to do on this. All right. So we've talked about systems of linear equations before, where two lines intersect each other. And remember, the solutions to a set of inequalities are where the graphs of equations intersect each other. So the solutions, so when it says to solve it, you're looking for where do they cross. So the solutions to a system of equalities are where the graphs of the equations intersect each other or cross each other. So if you think of this as two lines intersecting, there is a single point. If you think of it as, and that it would be a system of linear inequalities, if you have, say, a parabola and a line intersecting, you could have up to 2 points. And if you have two parabolas intersecting, for example, that could also have 2 points of intersection. So those are just 3 examples of systems of equality. So 2 equations that when you graph them, they cross. So previously we have looked at systems of equations in 2 variables and systems of equations in 3 variables. We are looking at systems of nonlinear equations, but just in 2 variables. So we're not worrying about having to solve for z or anything. So just the x and the y. But just like we did those by graphing substitution or elimination, we're going to be doing these by graphing substitution or elimination also. So in order for it to be a system of nonlinear equations or equalities, a system of nonlinear equations, remember the word linear means line. So nonlinear means at least one equation is nonlinear. So at least one equation is not a line. So this would be the system of linear equations, but both of these cases would actually end up being a system of nonlinear equations. Even though that one has a line, it has only at least one of the graphs is not a line. So it has a parabola that is nonlinear. Okay. So we have 3 possibilities of solutions. Let's look at some solution possibilities. Let me slide that up. Solution possibilities. The first possibility, we'll call that option A, is no solution. So if you have a parabola and then a line that just never goes through that parabola, or if you have 2 parabolas, like one is above the other, so that they never intersect. So if we define the solution to a system of equalities as where they intersect, if they never intersect, there is no solution, right? So that would be no solutions, or no solution. Option B would be if you have, for instance, a parabola, and then you have a line that just touches it, kind of grazes it on the edge. It only touches it at one point. Or if you were to have 2 parabolas, and they are, for instance, back to back. I didn't draw those super well, but if you draw those back to back, so they have 1 point where they touch. Again, I should have drawn those a little bit closer. Then they have 1 solution. If they only touch at 1 point, then they only have 1 solution. And then our last possibility, so if you have your parabola line going through that parabola, then you end up with 2 points of intersection. Same thing if you have two parabolas. You have one parabola going up and one parabola going down, and they could both be going up, but you're not going to have, well, you could have, yeah, we're not dealing with that. You could actually have up to 4. We're gonna keep it simple and look at a maximum of 2 points of intersection. So, in this case, you could have 2 solutions. All right, so those are our 3 possibilities right there. Give me a second as I make a mess. Now we're going to look at solving these 3, or solving systems of nonlinear equations, or nonlinear systems of equations. All right, so I'm going to switch over just to give myself some more room. And if at any point I go too fast, guys, because it's hard to pace myself without having you here giving me feedback and like having the visual feedback of pencil still moving. So if I go too fast, the paper notes are going to be up on the front desk. Feel free to, after the notes are finished, to come up and take pictures of them, get the paper notes to check out what you're doing. All right, so let's see. So 3 methods to solve nonlinear systems of equations. So, 3 methods to solve nonlinear systems of equations. So, method 1 is graphing. Method 2, substitution. And method 3, elimination. All right. So for method 1, which is graphing, again, so for method 1, graphing, you're going to graph each solution, or excuse me, graph each equation. The points of intersection, and I'm slanting up bad. The points of intersection there we go. So the points are the solutions. Which means that it is going to be super important for you to use graph paper and graph accurately. So let's look at an example. I'm going to do my writing on here and then my graphing on graph paper, but I strongly recommend that you have some graph paper close by. So our first example, example 1. Y is equal to x squared minus 8x plus 12, and y is equal to negative x plus 6. Well, I can already tell this x squared, so I have y equals x squared something something. This is going to be a parabola. So I have a quadratic formula, or excuse me, quadratic function, so a parabola. And then negative x plus 6, well, that's the equation of a line in slope-intercept form, y equals mx plus b. So I'm going to have a parabola intersected by a line. And you have to figure out where is it intersecting it at. So we are going to graph these. I need you to remember what we learned about how to graph parabolas. We can't do our brain flushes afterwards. We have to keep that information in our heads. So remember, when we have an equation in standard form, the vertex, the x value of the vertex is negative b over 2a, and the y value of the vertex is what you get when you plug that number back into the equation. So f of negative b over 2a. So that's how we're going to find out what our vertex actually is. So negative b over 2a, well, b is negative 8. So negative 8 is going to be positive 8. 2 times a, so 2, and then a is 1. There's nothing in front of that x squared, so that's a 1. So 8 divided by 2 times 1 is 2. So that's 4. The x value of our vertex is a 4. You can go ahead and write that down. All right, so to find the y value, I'm going to take this 4 and plug it back in for x. So I'm going to have y is equal to, instead of x squared, y is equal to 4 squared minus 8, and instead of 8 times x, 8 times 4 plus 12. So simplify that. 4 squared is 16. Negative 8 times 4 is negative 32. So plus 12. And then just add and subtract straight across. Oops, sorry guys. Give you a second to write that now that you can see it. So 16 minus 32 is negative 16. Negative 16 plus 12 is negative 4. So the y value of our vertex is negative 4. All right. So I'm going to draw a graph. This goes with example 1. So I just set up y-axis. Okay, so my vertex is at 4, negative 4. I'm going to have my axis of symmetry is going straight through that point. Put it in orange just kind of so we can use it for reference. And remember, when you graph a parabola, whatever your a is, remember our pattern of right 1, up 1, right 2, up 4, right 3, up 9, right 4, up 16. You're going to multiply that number by whatever is, or multiply this number by whatever is in front of your x squared. Here, it's a 1. It's invisible, but it's a 1. So it's going to stay the same. So from my vertex, I'm going to go right 1, up 1, right 2, up 4. And if I can, right 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I could go right 4, up 16. But I don't think that's going to fit on my graph. And since this is the axis of symmetry and parabolas are symmetrical, I'm going to do the same thing on the other side of that axis of symmetry. I'm going to go left 1, up 1, left 2, up 4, left 3, up 9. And then I'm going to do my very best connect those in a gentle parabolic curve. It is important to be as accurate as you can when you're looking for your points of intersection on a graph. So that is the parabola that goes with y equals x squared minus 8x plus 12. All right, so we also need to graph the point, or the line, excuse me, y equals negative x plus 6. So if we think of this as slope-intercept form, so my y-intercept is 6, so I'm going to go up 1, 2, 3, 4, 5, 6, and then I have a slope of negative 1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, and I'm going to keep following that pattern as far as I can. And then I'm going to use a straight edge and draw that line, fill in that line. Let's see if I can get it perfectly lined up. Okay, so draw that line. And then you should have your 2 points of intersection, which if you drew this very carefully, you should be able to identify. So this point right here is the point 1, so I went right 1 and up, 1, 2, 3, 4, 5. And this point is the point, let's see, I went right 6 and up 0, so 6, 0. So using my graph, the solutions to this example, so the solutions are 1, 5, and 6, 0. So those are the solutions. So the trick to this is you have to remember how to graph parabolas, but then once you do that, and there is going to be one fraction of this type on your homework, so you need to graph exact. Like you need to make your graph as neat and straight and perfect as you possibly can, or it's not going to come out right, okay? All right, so take a second, get caught up on that. See if I can zoom out a little bit. Maybe you can see the whole thing at once. There you go. All right, so that is how you solve systems of nonlinear equations by graphing. You graph both equations and you find the points of intersection. Okay, so take a second and then we're going to move on. All right, and remember the actual paper notes will be up on the front desk, so you can copy them down if you need to. All right, so just for room's sake, I'm going to move on to another sheet of paper, and we're going to look at method 2. Method 2, substitution. So with substitution, you're going to solve one of the equations for one variable, one of the variables. So solve one of the equations for one of its variables. And then you're going to plug or substitute. So plug it back into the other equation and solve. All right, so let's look at an example. Example 2, we'll call this. We have the equations x squared plus 2x minus y equals 5, and the equation 2x plus y equals 7. Okay, so we are going to look at these, and you have to decide what is the easiest variable to solve for. To me, it looks like your second equation, solving for y, is going to be easiest. So, solve the second equation for y. So 2x plus y equals 7. So to get y by itself, we're going to subtract 2x from both sides. So y equals negative 2x plus 7, or you may have written 7 minus 2x. Either one is fine. All right. So after you have solved for y, you're going to substitute this. By this, I literally mean this negative 2x plus 7 in for y in the first equation. So I'm going to take my first equation, that x squared plus 2x minus y equals 5, but instead of a y, I'm going to write negative 2x plus 7, because that's what y is. So x squared plus 2x minus, and instead of minus y, minus, but make sure you use your parentheses. Always use parentheses. When in doubt, parentheses. Negative 2x plus 7, and then equals 5. And I was able to write negative 2x plus 7 here instead of a y, because that's what y is equal to. Negative 2x plus 7. All right. So next thing that I want to do is simplify. So I've got negative 2. I'm going to distribute this negative. Remember, think of it as a negative 1 if you need to. I'm going to distribute that through my parentheses. So I'm going to have x squared plus 2x, and then negative 1 times negative 2x, plus 2x, and then negative 1 times 7 minus 7 equals 5. So I can simplify that. Well, I can combine my like terms, so x squared and then 2x plus 2x was going to be 4x. So plus 4x, and then I have a negative 7, and then I've got this 5 over here. So I can actually subtract 5 from both sides and move it over here with the rest of the numbers. So negative 7 minus 5 is negative 12 equals 0. And here I have an equation that I can factor. You can do it with whichever method you want. You can do it completing the square, box and x, quadratic formula if you really want. But when I look at this, there is not a leading coefficient, or our leading coefficient is 1. So I can think, what two numbers multiply to give me a negative 12 and add to give me a positive 4? And remember, if this number is negative, your C value is negative, since you're multiplying, the two numbers are going to have to be different signs. So I'm going to have my two parentheses, x and x are going to go in the first one. And since to get a negative, it's going to have to be a positive times a negative equals a negative. 1 is going to be positive and 1 is going to be negative. So two numbers, multiply to give me a negative 12, add to give me a 4. You can make your list of variables if you need to, but 6 times negative 2 is negative 12. Also, 6 minus 2 is 4, or 6 plus negative 2. So 6 and 2 are going to go there, and that's equal to 0. So to find x, I'm going to take each set of parentheses, so x plus 6, and set them equal to 0. X plus 6 equals 0, x minus 2 equals 0, and solve both of those for x. So subtract 6 from both sides, so x equals negative 6. Then on this one, add 2 to both sides, so plus 2 plus 2, x equals 2. All right, so after I have found x, I have one more step on substitution. One more step. I have to take these x's and plug them back in. So plug x's in separately. So I'm going to have to do x equals negative 6 and x equals 2 as two separate equations. And separately. And solve for y. Okay. So first I'm going to look at x equals negative 6. And guys, you can plug it back into any of these equations. And since this equation, this 2x plus y equals 7, is the same thing as this equation, I just solved for y. To me, seems like it's going to be easiest to plug these back into this equation because you already have y equals something. So I'm going to first take that negative 6 and I'm going to plug it back into that y equals negative 2x plus 7. So y equals negative 2 times negative 6 plus 7. And I'm going to do the same thing for x equals 2. Y equals negative 2 times 2 plus 7. And then solve those. So negative 2 times negative 6 is 12. Let me just say that's 12, and 12 plus 7 is 19. So the ordered pair, negative 6, that was our x value, and then 19 as our y value is a solution. And then over here, negative 2 times 2 is negative 4. Negative 4 plus 7 is 3. So the ordered pair 2, 3 is one of our solutions. So negative 619 and 2, 3 are the 2 points of intersection for that parabola and that line, if you were to graph it. All right, so take a second, write all that down. And then we're going to do one more method to get you ready for your homework. All right. And again, if there's any part of this that you need to see again, they're going to be up on the front desk, and you can come just look at them. All right. So our last method, method 3. Elimination. Elimination. So with elimination, you're going to add the two equations together so that one of the variables cancels out. So all the x's are going to cancel out, or the y's are going to cancel out. One of the variables cancels out. You may not, but you may have to multiply one or both of the equations first. One or both equations first. Okay. So let's look at example 3. If you have the equation y equals x squared minus 4x plus 6, and you have the equation y equals negative 5x squared plus 20x minus 12. Okay. So I have two options here. I could either multiply one of these equations by a negative 1, so I would end up with a negative y, and when I add them together, the y's would cancel out. But on this one, I notice that my x's are multiples. So I have an x squared, and then I have a negative 5, so 1 and negative 5, and then here I have a negative 4 and a 20. So I can also multiply, you could do the negative 1 to either one, but I could multiply this whole top equation by a negative 5. And let's see what happens when I multiply it by a negative 5. Okay, so negative 5 times y, well, that's going to be a negative 5y. Negative 5 times x squared, it's going to be a oh, that should not be a negative. Okay, maybe I will learn how to edit before we get to this. But if not, that should have been a positive. Because if I multiply by a negative 5, I'm going to end up with negative 5, negative 5. That's not going to do me any good. So this should not be a negative 5. It should just be a 5. Which means 5 times y would just be 5y. So then 5 times x squared is going to be 5x squared. 5 times negative 4x is going to be negative 20x. And 5 times 6 is positive 30, so plus 30. So this is my top equation, just multiplied times 5. Now if I add this first equation and the second equation together, so y plus 5y is 6y. But then negative 5x squared plus 5x squared, they cancel. 20x minus 20x, those cancel. And then negative 12 plus 30 is 18. So that whole thing, once I've multiplied the top equation times 5 and added them together, simplifies down to 6y equals 18. So then to get y by itself, divide both sides by 6. So y is equal to 3. All right. So then I take that y and I'm going to plug it back in to either equation. I'm going to plug it into my top equation just because it has a little bit smaller variables in front. So it's y equals 3. So I'm going to take this y here and replace it with a 3. So 3 equals x squared minus 4x plus 6. All right, so I still have to solve this. Okay, so 3 equals x squared minus 4x plus 6. So I personally, creature of habit, I prefer my parabola to be on the left side. So I'm going to swap these around. So I'm going to just put them on opposite sides of the equal sign. So x squared minus 4x plus 6 equals 3. Okay. I'm going to move my 3 to the left. So subtract 3 from both sides. So x squared minus 4x plus 3 equals 0. All right. So again, there are a number of different ways that you could solve this. You could do quadratic formula. You can complete the square. A ton of different ways. But the simplest, and so the first thing that I'm always going to ask, are there two numbers that multiply to give me my last term and add to give me my middle term, since a is 1. So, two numbers that multiply to give me 3, positive 3, and add to give me a negative 4. Well, negative 1 times negative 3, negative 1 times negative 3 is a positive 3, and negative 1 plus negative 4, negative 1 plus negative 3 is a negative 4. So, I can just separate this out to x minus 1, x minus 3 equals 0. Factor it out. And double check, negative 1 times negative 3, positive 3. Negative 1 plus negative 3 is going to be a negative 4. Again, set these each equal to 0. So x minus 1 equals 0, x minus 3 equals 0, and if you need to add the 1 to both sides, go ahead, but x equals 1, and x equals 3. This one's a little tricky, not too tricky, but remember, this x goes with this y, and this x also goes with this y. So your points of intersection are 1, 3, and 3, 3. So these are the solutions. This is equal to x when y is equal to 3, and x is equal to 3 when y is equal to 3. So these are your two solutions. All right, friends. So I'm going to go ahead and let you get started on your homework. I know you're still going to have a lot of questions, and I apologize that I am not here to work more examples with you and more questions with you. But I want you to go ahead and give it your best effort. It is the pink 3.5 practice A. Worksheet. And the key to that is actually up here on the desk. The key is on the front where it just has the answers, but then after that it shows you the work. So I've got the graphs graphed, and I've got all of my work shown. On numbers, I think it was 9 and 12, I factored a little bit differently. So on these, on 9 and 12, you would use the box and diamond, or diamond and box. I guess X and box. I don't know, however you guys learned it. For 10 and 12, if you come to check them out, because my method is gonna look a little weird to you guys. So remember, there can be no solution, and I will say that there's only one no solution on this entire page. Well, no, actually, there's technically two, but of the ones that you have to solve, there's going to be two no solutions. One is going to be fairly obvious, I think, and not require you to do any actual math. You guys can take the hint on that. And then the other one is going to be in the bottom section under solving using elimination. So there will be one no solution in this section. All right, so again, the answer key will be up at the front. Don't just come don't come copy the answer key, but after you have worked them, feel free to check your work, or if you get stuck on one and you just can't figure it out, no one around you can help you or figure it out with you, come look at my work and see if that helps. Let's see if there is anything else. This will be due tomorrow. I'm going to have you guys turn it in, and I will grade it and get it back to you. So that's pretty much it. And again, if you have questions, write them on a piece of paper and put them in the bin to your right, and I will try to get back to you in tomorrow's video. Good luck. I'm proud of you. You can do it. Make good choices and be kind.